Chapter 1 from the textbook discusses fundamental concepts, and you should have covered many of these sections in Tech Math 1. What we're going to start with today is section 114, which talks about ratios and proportions, and then in the next video we'll talk about section 115, which deals with variation. Now, first of all, we need to talk about a ratio and a rate. Now, a ratio compares two like units. So, for instance, inches to inches, miles to miles, pounds to pounds. A rate, on the other hand, compares to unlike units. And you've seen these in your everyday experience. Every time you drive, you have a rate of miles per hour or kilometers per hour, depending on which one you're looking at. Pressure is another rate, which is force per unit area. Mass density is mass per unit volume. Power is work per unit time. All of these are rates, and both of these are similar in the fact that they are fractions that compare these two units. So, for example, if we want to find the ratio of 35 centimeters to 14 centimeters, then we would just write it as such: 35 centimeters compared to 14 centimeters. Now again, these are like units, so those centimeters will divide to be 1, and then we can reduce this fraction. These are both divisible by 7, and we're left with 5/2 as our ratio. This next example is a little different. You could use it as a rate, but technically these are both units of length, so we can convert one to the other. I'm going to convert the yards to feet. Now, if we know we have 12 yards, we know that there are 3 feet in 1 yard, and this is what is known as unit conversion or dimensional analysis, and we end up with 36 feet. So if we want the ratio, we are going to have 240 feet compared to 36 feet. Again, the feet divide to be 1, and these are both divisible by 12. We are left with 20/3. One other thing to point out, there is another way that we can write a ratio, and that is to write it as 20/3. And you might see the textbook use it in this fashion. Now let's look at some applications of ratios and rates. Suppose you're trying to find the mechanical advantage of a simple machine, such as a pulley system. This is defined by the following ratio: the resistance force divided by the effort force. We want to know what the mechanical advantage of a pulley system is, in which it takes 50 pounds of effort to lift 7,000 pounds of load. So in this case, MA, the resistance force is the amount that the actual load weighs, so this is 7,000 pounds, divided by our effort force, which is 50 pounds. This tells us this is 50 pounds of effort. And again, we can simplify this. They're both divisible by 10, and then we have 700 divided by 5, which comes out to be 140. Again, pounds divided by pounds would also divide to be 1. And so this is telling you essentially that because of this pulley system, you can lift 140 times the effort you put in. Another example here, again, mechanical advantage. This time we're talking about a hydraulic press, so something that's using fluid into a cylinder to produce pressure. And the mechanical advantage for a hydraulic press is the RL squared, where RL is the radius of the larger piston, divided by RS squared, which is the radius of the smaller or effort piston. So again, the amount that you have resistance divided by the amount that you have in effort. We want to know the mechanical advantage of a hydraulic press that has pistons of radii 30 inches and 1 foot. Again, the larger piston and the smaller piston. So again, we've got two different units here, so we need to convert this 1 foot to be 12 inches. And if we go with our mechanical advantage here now, this the larger radius, and again this is just plural for radius, is 30. We have to square it, and we're dividing by 12, and we have to square it. So we end up with 900 divided by 144. And again, we can reduce this fraction, and we come up with 25 fourths. So in this case, for every 4 essentially units of effort we put in, we get out 25 units of effort. So I want you to try this last example, 114.5. Again, you're given the ratio, do the division and simplification, and then resume the video to check your answer. So in this case, you should have found that your power gain is 25. So essentially, you get 25 times more output than you do input in this case. So this concludes the video on rates and ratios. The next video will discuss proportions.